Question 26 is a right angle triangle question. You can see you've got your right angle triangle here, but interestingly, it's divided up into a smaller and a larger triangle. The issue is that this one is not right angled. You can see that the angle is not the same as the one there. It wouldn't work if it was. So actually you have to think about it as being two different triangles that are overlapping each other. Okay, if you imagine we've got our first triangle, which is the whole thing together, and that is BDA, and then you've got the smaller one which overlaps it, and that is BCA. Okay, and they are both going to be right angled. Now, what we're wanting is the angle here, but that angle is not in either of those triangles. Actually, the bigger angle here take away the smaller one there. So if we can work out this angle, then we can work out the angle there. Okay? So what do we know about it? Well, we've got some lengths already labelled on it. We've got 20 centimetres as our length AD, and we've got 12 centimetres as our length AB. Now, interestingly, the ratio of BC to CD is 1 to 3. So BC to CD is 1 to 3. Yeah, another way of thinking about that is that this is 1/4 of that line, and that is 3/4 of that line. So that means that we can work out this total length here from B to D, then we can work out the smaller one there. Now, how can we find the total length? Well, conveniently, it's a right angle triangle, therefore we can use Pythagoras. Okay? So you know your Pythagoras' theorem, a squared plus b squared equals c squared, so the two shorter sides being squared will add up to make the longer side squared. So our two shorter ones are 12 and are unknown, yeah, so BD. And that adds together to make the longer one, which is 20, again, squared. So just put my values into the equation, knowing that that's going to be the longest side, the one opposite the right angle. So we've got 144 plus BD squared equals 400. If I then subtract the 144, I'm left with BD squared equals 256. And then to find BD, I need to take the square root of 256, which I'm pretty sure I know the answer to, but since I have a calculator, I'm going to check. Okay, so that means that BD, that whole length there, is 16 centimetres. I'm going to add that onto my little diagram up here. So I'll put on the measurements that I know. So I know that is 12, I know that is 12, I know that's 20, I don't know that length, and I know that this is 16. And BC is 1/4 of that, and 1/4 of 16 is 4. Okay? Now that I know two of the sides on each of them, I can use that to work out an angle. And I can do that using trigonometry. So you will remember SOHCAHTOA. Yeah, and we tend to present that using little triangles. So you've got the sine of the angle equals the opposite over the hypotenuse. Same presentation, the cosine of the angle equals the adjacent over the hypotenuse, and the tangent of the angle equals the opposite over the the adjacent. So with those three triangles, I need to work out which one I'm using. I'll use the same one for both because I've got the same pair of sides for both, so I'm effectively going to ignore that 20 now. And when I'm finding my angle, what am I using? Well, I've got the three sides, so I have the hypotenuse, which is the longest side, and then I've got the opposite, and I've got the adjacent. Opposite and adjacent. Opposite the angle, next to the angle. Opposite the angle, next to the angle. Okay? So if I've got opposite and adjacent, which one am I going to use? I'm going to use my tan rule. Okay, I'll draw it out a bit bigger for you. So opposite over adjacent, tan theta. That just means the tan of the angle. Okay? So for each of those, I need to work out what the angle is going to be. So it'll be, if I cover up the one I'm trying to find, I cover up the angle, I have to do opposite divided by adjacent. So tan theta equals opposite over adjacent. So the opposite is, I'll do the top one, 16 over 12. So tan theta is 16 over 12, but I actually want to find out what theta is, so the angle, not the tangent of the angle. So theta is going to be, and we use the inverse, because I'm getting rid of it from this side, I'm getting rid of it from the other side, so I'm doing the inverse of tan. The 16 over 12. It's better to do it that way than to try and work it out over here and then put your decimal in. So theta equals inverse of tan, 16 over 12. Inverse of tan is on your calculator, so above tan. So shift tan and then 16 over 12, close brackets, equals. And it comes out as 59.033. And we're going to do the same thing for the other triangle. So theta equals tan, inverse of tan, and this time it's going to be 4 over 12. So if I now do the same thing, but for 4 over 12, I get 20.483. And then if I subtract those two angles, that will give me the angle we're trying to work out. So 59.033, take away 20.483, and it leaves me with 38.5497. And I want it to one decimal place, I'm going to cut it off there, 38.5 degrees. Okay, it's a complicated one, and realistically it's for the higher sense who've actually done trigonometry in detail.